afternoon, everyone. So today there was a full syllabus test, or I think this is the last FST that you are giving. So we will discuss the questions, the important questions of this lecture, of this test. So let's start our discussion. I hope the test was good, your preparation was good, I hope, and ultimately you have to clear the exam. That should be your aim. Practice more and more, revise the questions that we have taken in the during the classes so that we can get good score. Okay. So now let's start our discussion with the questions. First question. Okay. If you see the question is asking, there is a uniform rod of mass m and length L. Find the radius of gyration. So the radius of gyration, if they are asking, so first of all, let's draw an little bit of diagram. There is a rod. This is the rod of mass something m and length L. Radius of gyration about an axis passing through a point. Let's suppose this is the center at a distance L by 4 from the center. So L by 4 from the center. This is the center, and L by 4 from the center. This is the axis, which is also perpendicular to the rod. About this axis, I need to find gyration. I hope you remember what is radius of gyration. So this distance is nothing but L by 4. So what I know, that the relation I is equals to mk square, where k is the radius of gyration and I is the moment of inertia about the axis about which you are calculating radius of gyration. So I is the moment of inertia about this given axis. So about this axis which is passing through the center, we know the moment of inertia. Using parallel axis theorem, we can calculate I. So I is equals to ml square by 12. This is about the axis which is in yellow color, about center of mass axis, which is ml square by 12, plus parallel axis theorem is md square. Mass is m, d is this distance L by 4, that is L square by 16 is equals to mk square. M can be cancelled out. I hope it's clear. So now after the cancellation of m, what you can write, this LCM is going to be 48. That is 4L square plus 3L square is equals to K square. So K is equals to, you can say it is 7L square by 48. So L can be taken out from the under root, and this is root of 7 by 48. This is going to be the answer. Correct answer is, so after seeing this, the correct answer would be L root 7 by 48. That is option number A is our correct answer. Is the question clear? Okay. Now moving further. One more question we are taking here. The question is, the current I in the given circuit is. So there is a circuit given. You can do it by using series parallel combination method. Very easily you can do that. What you can see, that this 1 ohm and this 1 ohm both are in parallel, and they are in series with this 2 ohm resistor, and this complete combination is again in series with 2 ohm resistor. So by using series parallel combination, you can get every current you want. But now I will describe some different method. Knowing this method is also very important. So try to learn this. I hope you will try and learn this method. I will redraw the diagram. Okay, this is 1 ohm. This is again 1 ohm. There is one 2 ohm resistor, 2 ohm, and there is one more 2 ohm resistor, and this is something connected like that. And there is one battery which is of 1 volt. I think it is clear. Now the next thing, the battery has a potential of 1 volt. So what we can take here, let's suppose this is the potential, low potential, that is 0. So this will be 1 volt. This will be 1 volt. So this 0 will be taken here. That is 0. So this is the 0 potential. The potential will remain same in the connecting wires. I think you should remember this line, and everybody remembers this as well. So whenever this wire is going, the potential will be 0 volt. Clear? So this is the point where 0 potential. Now there is a resistance. So potential will change. Let's suppose at this point potential is V. Similarly, this is 1 volt. The wire is going. So this is the point where wire going, that is 1 volt. Similarly, this is again 1 volt. Clear now? That is 1 volt. This is also 1 volt. And this point is V. This point is 0. Now we have potential at every point. So now the second step is divide the current. Divide the current. Potential V. So I am dividing current something like this is I1 is coming, this is I2 is coming, and this is I3. You can take any direction of current, you can take whatever you want, whatever the current you want, you can take I1, I2, and I3. This process hardly take 1 or 2 seconds. The process that I have taken till now, it will hardly take 1 or 2 seconds of yours. Now, everybody knows Kirchhoff current law. Everybody knows Kirchhoff current law, that is KCL. What it says, current entering the junction is equals to current leaving the junction. So at the junction of potential V, current entering the junction is I1 and I2. It should be equals to current leaving the junction, that is I3. Is there any problem in this? I1 plus I2 is equals to I3. This is nothing but KCL. Now, I1 can be written as I, you from Ohm's law, everybody knows, I think, that I is equals to delta V by R. Everybody knows. So I1 is moving through 1 ohm resistor, and the potential difference between these is 1 and V. So that is 1 minus V divided by R is 1 ohm. Plus I2 is again 1 minus V divided by 1 ohm is equals to I3 is what? Current is flowing in this direction, that is I3. So potential difference is V minus 0. V minus 0 divided by 2. Clear? So on this LHS, it will be 2 minus 2V. 2 minus 2V is equals to V by 2. You can cross multiply. So that will be 4 minus 4V is equals to V. So V is equals to 4 by 5. That means potential at V is 4 by 5. We want to calculate according to the question. I1 we want to calculate. So I1 will be what? I1 will be what? You can see that 1 minus V divided by R is 1 ohm. So that is 1 minus 4 by 5. 5 minus 4, that is 1 by 5 ampere. And 1 by 5 ampere is nothing but 0.2 ampere, which is option number A. Which is option number A. So is the question clear to you? You look at me. Whenever they are asking the current, go for this method. This method is generally called as node method. This method is generally called as node method. So go with the node method. Here you can use Kirchhoff current law to solve the questions. And whenever there are only one variable, or in fact, two variables can also be solved. Here, one variable was V. The only variable was V. You can take at least two variables and can solve this question without using any problem. It is better than series parallel combination. If you can't do it quickly, you should follow this rule. Okay, moving further for the next question. Okay, an ideal fluid is flowing in a pipe in a streamline flow. Okay, pipe has maximum and minimum diameter of something, this one and this one. Find out the ratio of minimum to maximum velocity. Okay, the question is saying something that there is a pipe which has variable cross section areas. You can assume it's something like that. You can assume it's something like that. Here area is maximum and here area is minimum. Okay. So from the continuity equation or equation of continuity, everybody knows that A into V is a constant. This is continuity equation. And if A into V is a constant, then you can see that A is reciprocal to V. Or what I can say more accurately, V is reciprocal to A. That means if area is less, then velocity will be max. Clear? Find out the ratio of minimum to maximum velocity, then that means minimum velocity over maximum velocity should be. It is reciprocal to area, na? When velocity will be minimum, area will be maximum. So that is going to be A max by A minimum. Now listen to me, area of cross section is nothing but pi r square. Or you can say pi. Let's suppose this has a radius r1 and it has a radius r2. So r1 square by pi r2 square. Pi and pi can be cancelled. That will be r1 by r2 square. But the question has given us diameter, so no problem. The ratio of radius is same as the ratio of diameters. That means no problem, we can use that. So V minimum over V maximum is equals to R1 is given as 6.4, that is 6.4 divided by R2 is given as 4.8 to the square. You can cancel out, that will be 16 by 9 if you square it. That will be 16 by 9. Let's suppose this is V1, A1, V2, A2. So V1 over V2 will be A2 over A1. Okay, I have written something incorrect, I think. Okay, I have used R1 and R2 in a wrong way. Okay, okay. I have written this in a wrong way. That's why answer is reversing. So you can check it out again. You can check it out. I have placed R1 and R2 in correct way. So what I'm saying, V1 over VT is equals to A2 over A1. This is A1, this is A2. So again, I am writing V1 over V2. This is the minimum velocity. This is the maximum velocity. So V1 over V2 is nothing but A2 over A1. A2 is pi R2 square by pi R1 square. R2 square is the lowest value and lowest value is what? 4.8. divided by 6.4 square. That is 3 by 4. And square, if you do it, it will become 9 by 16. So velocity minimum by velocity maximum is nothing but 9 by 16, not 16 by 9. It should be 9 by 16. I hope you got it correct. That is 9 by 16. Moving further for the next question. A block of mass 10 kg is suspended from a string of length 4 meter. Okay. When pulled, okay, look at the situation. The question says that there is a block of mass something 10 kg. This mass is suspended. This is 10 kg by a string of length 4 meter. Clear? When pulled by a force, that means when pulled by a force along horizontal from midpoint, that means from the midpoint, from this point, it is pulled along horizontal by a force F. So now can you imagine what the diagram should look like? It should look like something like this. Something like this. And this is force F. And it makes some angle 45-degree from the vertical upper part of the string. And there is a block of mass 10 kg. Clear? This is the diagram, final diagram. Value of F they are asking. They are asking the value of F. So first of all, this is 10 kg block. So this is going to be 100 Newton mg. There is going to be some tension T1. Tension always occurs in pair T1, T1. And there will be a tension T2. Clear? Now another thing is, you can clearly see that T1 is going to be 100. T1 is equals to 100. You can see that. Now we need to calculate the value of F. So using Lemmy's theorem, first of all, try to write down the angles. This is 90. You can see that. This angle will be or I will say this angle will be, this is the vertical line. So this angle will be 90 plus 45. 90 plus 45. And this angle will be 180 minus 45. Why so? Because this angle is going to be 45. Why 45? Alternate interior angle. So we know the angles. Lami's theorem says from Lemmy's theorem, what you can write? Force F divided by the opposite angle, that is sine 180 minus 45 is equals to the force T1 divided by opposite angle, that is 90 plus 45. Now T1, this is T1. Now similarly you can write for T2 as well, but T2 is not required in this question, so I am not writing for T2 because T2 it will become T2 over sine 90 and we are not required to calculate T2. That's why I am not dealing with that. So in this situation, sine 180 minus 45 is sine 45. Sine 90 plus 45 is equals to cos 45 and both have same values. So these two can be cancelled. So F is equals to T1. F is equals to T1 is what? 100. The correct answer is 100 Newton, which is option number A. Option number A. I hope it is clear. Can we move for the next question? Yes, we can. Next question is again there. This question can be easily done using series parallel method. Very easily done. But I have solved it using node method in the previous question. So I will try to solve it using node method again. so that you can understand what is node method. Okay. There is electric circuit shown in figure. Find potential difference between point A and B. These are the 2 points A and B, and we want to find the potential difference between them. One thing is that there is a diode, and you can see that this diode is connected with the positive terminal. The P region is connected with the positive terminal. This is the P region, and it is connected with the positive side of the battery. So this diode is forward wise. This diode is forward wise. So it will behave as a closed switch. It will behave as a closed switch. So final ultimate diagram will look something like that. I will draw it using some other color pen. One resistor, one more resistor, one more resistor, and there is a battery of 30 volt. 30. This is of 10 kilo ohm. This is again 10K. This is again 10K. 10K ohm. You can see that. Now, the first thing that we should do is we want to calculate the potential difference between point A and point B. Clear? So first of all, starting with the battery, if I see this point is 0, this point is 30 volt. So whenever the wire is going, it is going to be 0, 0. Clear? Whenever this wire is going, it is going to be 30. So at this point, it is 30. And there is a resistor, so potential will change. Let's suppose at this point, potential is V. So this is the same point as this point is also V. Clear? Now we need to divide the current. We need to divide the current. So let's assume some current here. Let's suppose I1 is coming, I2 is going this way, and I3 is going this way. Clear? I1 is coming, it is dividing in two parts, I2 and I3. No problem in that. So what you can write using Kirchhoff law, Kirchhoff current law, what you can write is I1 at this junction, you can see at this junction, if you see, current entering the junction is I1 and current leaving the junction is I2 plus I3. I1 is equals to I2 plus I3. It will not take lot of time of you. So I1 is what you can, how you can write I1? I1 is the current in this 10 kilo ohm resistor, in this one, in this resistor. Current is what? Delta V over R. Delta V is what? Current is 30 minus V. 30 minus V divided by 10 kilo ohm is equals to I2 is what? I2 is in this resistor. That is V minus 0. That means V by 10 plus I3 is again V minus 0. That is V by 10. This 10 kilo ohm, 10 kilo ohm, 10 kilo ohm can be cancelled. So you can see 30 minus V is equals to 2V. This is 3V equals to 30. So V is going to be 10 volt. And we want to find the potential difference of A and B. So potential at point A is 10 volt, at B it is 0. So potential difference VAB is nothing but 10 volt. Is the method clear to you? Is the method clear to you? I hope it's pretty much clear. Moving further for the next question. Moving further. Choose the correct PV graph of ideal gas for the given VT graph. So there is a graph. Is this velocity time graph? Or is it volume and temperature graph? So volume and temperature graph is given. Okay, and we need to find the pressure volume graph, PV graph, out of the 4 options. Now listen. First of all, there are 2 processes which are very easily understood. Let's suppose this is process number 1. This is process number 1. This is process number 2. This is process number 3. So from the diagram, what I can conclude, process number 2 In this process, volume remains constant, so this is isochoric. Clear? Process number 3 is nothing but temperature is remaining constant, so this is isothermal. Now for process number 1, if you can see, for process number 1, what I can see is that this is V proportional to T. V proportional to T. And V is proportional to that means it, for example, you know that PV is equals to nRT, or you can say V is equals to nRT over P. And they are saying V is proportional to that means this whole term is constant. That means P is constant. So this is isobaric process. Isobaric process. So now we know all the processes. We need to draw the PV graph. Let's suppose this is P and V. P and V. Now, process 1 is isobaric. Process 1 is isobaric. That means in process 1, pressure remains constant. Pressure remains constant. This is some isobaric process. This is some isobaric process. Clear? And in the process, you can say temperature, the volume was increasing in pressure 1. In process 1, volume 1, process 1, volume was increasing. So that can be written as like this. And this is our X, this is our Y. This is process 1. Now process 2 is isochoric, which is from Y to Z. Isochoric means volume remains constant. This is Y to Z. Clear? Now the third process is isothermal. That means temperature remains constant and it is from Z to X. Isothermal process Z to X. And in this process, volume was decreased. So this is isothermal compression. Isothermal compression. So this is the complete process X, Y, Z, and which is option number first. Option number A is the correct option. Another question. A ring is rotated about diametric axis. This is the diametric axis which is given by omega in a uniform magnetic field perpendicular to the plane of the ring. If initially the plane of the ring is perpendicular to the magnetic field, find the instant of time at which EMF will be maximum. So it's a time period of rotation is given as 10 seconds according to the question. Time period is given as 10 seconds. Now listen to me. When this ring will be rotated, the flux with it will change and some induced current is processed in the ring and EMF will also be induced. This EMF, I think you know that this EMF is given by E is equals to E naught sine omega t, where E naught is the maximum value of EMF and omega t is the angle. Omega t is the angle. Now, this is the induced EMF. They are saying find the instant of time at which EMF will be maximum. So this is the equation of induced EMF. This EMF will be maximum when sine omega t is maximum. When sine omega t is maximum, so I will write for maximum EMF, sine omega t should be maximum. That means sine omega t should be equals to 1. Is it clear? So that means omega t should be 90 degree because sine 90 is 1. What does it mean? P is equals to pi by 2 omega. Clear? So pi by 2 omega is nothing but 2 pi by t. So t can be written here. Pi and pi can be cancelled. That will be t by 4. So at time t by 4, the EMF will be maximum for the first time. So at time t by 4, t is given as 10 seconds, that is 10 by 4. So you can divide it as 2.5 seconds. I hope it is clear. I hope it is clear. The next is when it will be minimum. When it will be minimum. So for minimum, I will write for maximum, in place of maximum, for minimum EMF, sine omega t should be -1. And sine omega t -1, that means omega t should be 180 degree, that is pi. T is equals to pi by omega, that is pi by omega is 2 pi by t. Pi and pi cancel. So t by 2 is nothing but 5 seconds. Which is option? Which option is correct according to this 2.5 and 5 second? 2.5 and 5, 2.5 and 5, which is option number A. Clear? This equation, I think you have studied in AC generator. Another question. A telescope has magnifying power 5. Magnifying power is 5. Length of the tube is 60 centimeter. Then the focal length of eyepiece is. So if I talk about telescope, what you know about telescope, there is a objective, there is a eyepiece. Clear? And this separation is known as length of the tube. And this separation is given as FO plus FE. This separation is given as FO plus FE. Clear? Now magnifying power is FO upon FE, which is given as 5. So what you can write as 5 is equals to FO over FE. So you can conclude here FO is equals to 5 times FE. What is FO? Focal length of objective. FE is focal length of eyepiece. That's our equation number first. Now it is also given length of the tube. Length of the tube means FO plus FE is equals to 60. So FO we can place here, that is 5 FE plus FE is equals to 60. So FE is 10 centimeter. This is the easiest question. FE is 10 centimeter. Clear? Another question. If relative permittivity and relative permeability of a medium are 3 and 4 by 3. Okay. So write down something. Relative permittivity, that is epsilon r is equals to 3. Mu r is equals to 4 by 3. The critical angle of this medium. Critical angle is what? Theta c is equals to sine inverse mu of rarer medium divided by mu of denser medium. Is it clear? Now, permittivity and permeability is given. If these two quantities are known, then from these quantity we can calculate the speed of the light in that medium. We can calculate the speed of light in that medium. So that means you need to change this relation with in terms of speed. So that is sine inverse. You know that mu is equals to c by v, or you can say mu is reciprocal to v. So if I say mu r over mu d, it will become velocity in a denser medium to the velocity in rarer medium. This is the relation in terms of velocity. Now the other medium is not mentioned, so we are assuming it to be air or vacuum. We are assuming it to be air. So velocity in air is nothing but c, and velocity in denser medium we can calculate. velocity in a denser medium is nothing but c over root of, yesterday class we have remembered the formula mu r into epsilon r. So if you place the value, it will become c divided by mu r is 4 by 3 into 3 cancelled, that is c by 2. So new velocity is c by 2. Just place the values. Theta c is equals to sine inverse. Speed in denser medium is c by 2. And in rarer medium, it is air, it is c. C and C can be cancelled. Sine inverse 1 by 2, which is nothing but 30 degree. It is option number C. I think it is clear. Moving for the next question. In full scale deflection, it should be if full scale deflection current in galvanometer of 100 ohm resistance is 1 milliampere. Resistance required in series to convert it into voltmeter of range 10 volt. Of range 10 volt. Okay. It is a question of conversion of galvanometer into voltmeter. I think you remember the equation, or if you don't know, then I will tell you. Let's suppose this is something, some resistor R, along which I need to connect a voltmeter. So I have connected a galvanometer, which has some resistance G and a series resistor R. So this whole combination is known as voltmeter, and this, the potential, the range to be measured is V. And the current in this is IG. This is full scale deflection current. This is full scale deflection current. Now, if you can see that these two arms are parallel to each other, so equation you can remember, or you can directly make that if these two branches are parallel, so their potential will be same. That means V should be equals to the potential across this branch is V is equals to IR. Current is what? IG, and resistance is what? G plus R. G is the resistance of galvanometer. R is the resistance which is connected in series. So R is going to be asked in this question. G is given as 100 ohm. Just place the values. V is equals to 10 volt given. The range is given as 10 volt. This is nothing but range. 10 volt is equals to IG is given as 1 milliampere. That is 10 to the power minus 3. Resistance of galvanometer is given as 100 plus R they are asking. So you can see that this is going to be 10,000 is equals to 100 plus R. I have transferred this 10 to power minus 3 either, so it will become positive 10 to power 3. It will become 10,000. So R is equals to 9,900, or you can say 9.9 kilo ohm, which is option number B. Which is option number B. Clear? Next question. There is a screw gauge. So, okay, screw gauge we have studied in unit and dimension chapter, in measurement chapter, I think. A screw gauge advances by 3 mm in 6 rotations. There are 50 divisions on circular scale. Find the least count. I will give you some 30 seconds. What happened? I will give you some 30 seconds to solve this out. Anybody remembers the formula for least count? Least count is equal to pitch divided by number of divisions in circular scale. Which divided by number of divisions in circular scale. Circular scale has 50 divisions according to the question. It has 50 divisions according to the question. And what is pitch? Pitch is what? Distance moved by, on main scale in one rotation. I will tell you what is pitch. Pitch is distance moved on main scale in one division, in one rotation. So here it is says the question says it moves, advances means moves 3 mm in 6 rotation. In 6 rotation it moves 3 mm. So in one rotation it will move 1 by 2 mm. So pitch is what? 0.5 mm. So least count will be 0.5 mm means 10 to the power minus 3 divided by number of divisions in circular scale are 50. You can solve it out. That is 10 to the power minus 5 meter. This is 10 to the power minus 5 meter. So you can say it is going to be 10 to the power minus 3 centimeter because options are in centimeter. So I will write it in centimeter. So according to this, which option is correct? Option B is correct. Clear? Next question. All these questions were taken already, I think, during the classes. This is the question from electrostats of potential and electric field. Potential is given something V is equals to minus 5x plus 3y plus root 15z. Clear? Magnitude of electric, they are not asking the electric field, they are asking the magnitude of electric field. They are asking the magnitude of electric field. I think everybody remembers if potential is given, then electric field can be written as field in the x direction is minus of partial differentiation of potential with respect to x. That means partial differentiation means you can consider y and z as a constant. So if I do the partial differentiation, I will get minus is already there and partial differentiation of this with respect to x is 5. That is minus 5. So minus minus plus becomes 5. Nothing else. Field in the y direction is negative partial differentiation of potential with respect to y. Now you can consider x and z as a constant. So constant has zero differentiation. If you differentiate, it will become 0. So differentiation, it will become of 3y. So differentiation of 3y is nothing but 3. Minus is already there, so it is minus 3. Field in the z direction is minus partial differentiation of v with respect to z. Minus is already there, and if you differentiate, these two terms are constant, only root 15. Root 15. So now I know the coefficient of field in the x, y, and z directions. So the resultant or the magnitude of field will be under root of addition of or the sum of these squares. That is ex square plus ey square plus ez square. If you square it, it will become, this is nothing but this is the method of getting the magnitude of a vector. For example, you have a vector. For example, you have vector A is equals to x I cap plus y j cap plus z k cap. So the magnitude of this vector is nothing but root of x square plus y square plus z square. That's what we are doing here. In this question, these ex, ey, and ez are the xyz components of field. By squaring them, we can get the answer. So ax square is 25 plus 9 plus ez square. If you root, this is root 15, it will become 15. So it is 40, 49. So it is root of 49, which is 7. This is our option number D. This is our option number D. I hope it is clear. Moving further for the next question. A fresh radioactive sample is given at T equals to 0. Okay. Initially, its decay fraction are 1 by 5 at time T1 and 4 by 5 at time T2. Okay. Decay fraction means what? Decay fraction means what? N over N naught. This is the decay fraction. It is given as N by N naught and it is given as 1 by 5. So one thing that you should know, N over N naught or N is equals to N naught e raised to the power minus lambda t. We know that. We know that now. So at time t1, this is 1 by 5 is equals to e raised to the power minus lambda t1. This is first. Secondly, you know that the decay fraction is 4 by 5. At what time t2? E raised to the power minus lambda t2. This is equation number 1. This is equation number 2. If I can divide these two equations, what I will get? This 5 and 5 can be cancelled. And I will get 1 by 4 is equals to e raised to the power minus lambda t1 divided by e raised to the power minus lambda t2. Clear? So 1 by 4 is nothing but e raised to the power lambda t2 minus lambda t1. So you can take lambda common, t2 minus t1. Clear? E raised to the power lambda t2 minus t1. Now taking log. If I take log, the question is asking us what is the mean life. If they are asking us the mean life, then you should remember mean life is nothing but 1 over lambda. So for the whole process, I need to calculate lambda. I need to calculate lambda. So if I take log, it will become ln 1 by 4, or you can say ln 1 minus ln 4, that is 0 minus ln 4 is equals to lambda t2 minus t1. Or we can cancel this negative sign as lambda t1 minus t2 ln 4. I have taken minus common here and minus minus gets cancelled. So lambda is equals to ln 4 by t1 minus t2. Put this value. So tau is equals to 1 by lambda means t1 minus t2 by ln 4. I think there is some typo. This is not t2 minus t1. This is going to be t1 minus t2 by ln 4. Okay. Okay, not this one, not this one. T2 minus T1 by ln 4. It should be T1 minus T2 by ln. So option B is going to be correct here. Moving further. In the following diagram, if V2 is greater than V1, this is the question from photoelectric effect. And the graph between photocurrent versus potential or the collector potential is given. Now, which relation is correct? They are asking. So you know that, I think everybody knows that this point indicates these points. The intersection point indicates stopping potential. They indicates stopping potential. And what is the formula for stopping potential? You know that V naught is equals to hc by lambda E minus psi by E. You know this relation. This is the stopping potential. Now you can see that stopping potential is related indirectly with the wavelength. That means more the stopping potential, less will be the wavelength. So V2 is more. So lambda 2 will be less. So lambda 2 will be less than lambda 1. Lambda 2 will be less than lambda 1, which is option number D. Moving further. For a series RLC circuit, okay, there is a series RLC circuit. There is one resistor, one inductor, and one capacitor. Okay, this is series RLC circuit. Resistance is given as R. XL is also equals to R, and XC is equals to, you can say 2XC is equals to R. That means XC is equals to R by 2. Now we know the values. The impedance of the circuit. Impedance of the circuit is under root. You know the relation, I hope. R square plus XL minus XC का whole square. Now place the values, that is under root R square plus XL is R, XC is R by 2. So R minus R by 2, that is R by 2. If you square it, will become R square by 4. So what is will be root of 5 R square by 4. Something can be taken out. What can be taken out? R can be taken out, that is R by 2 root of 5. So R by 2 root of 5 is in option A and option B. So we cannot predict the exact answer. For that, we need to calculate the phase difference, and phase difference is given as tan phi. For RLC circuit, I am saying tan phi is equals to XL minus XC divided by R. So XL minus XC is nothing but R by 2 divided by R, that is 1 by 2. So phi is equals to tan inverse 1 by 2. So which option is correct? Option B is correct. Option B is correct. Moving further. Okay. 3 plates of common surface area A are connected as shown. The effective capacitance, now 3 plates are connected. Let's suppose this is plate number 1, this is plate number 2, this is plate number 3. Now can you see that plate 1 and 2 can form one capacitor? Let's suppose this capacitance is C. Using plate 1 and 2, you can see that there is a capacitor forming. Using plate 2 and 3, another capacitor is formed. The gap between the plates is same, so its capacitance will also be C. So there are 2 capacitors of each of capacitance C. Now, we want to calculate the effective capacitance between points A and B. So you can clearly see that if there are 2 capacitors, let's suppose these are the 2 capacitors. These are the 2 capacitors. This is 1, this is 2, and this is 3. And you can see that where is point 2? You can say where is point A? Point A is at this point. This is point A. And point 1 and 3 are connected. Point 1 and 3 are connected. And this is point B. Clear? Now you need to identify the connection. If this is potential V, this is 0. So this plate is going to have potential V. This is having potential V. This is 0. This is 0. The 2 capacitors are in parallel combination. If they are in parallel combination, their effective capacitance, I can write C effective is equals to 2C. They are in parallel combination. 2C means 2. Capacitance of a parallel plate capacitor is A epsilon naught over D. So correct option is 2A epsilon naught over D. 2A epsilon naught over D, which is option number D. We can take one more question here. In this question, they are asking which gate it is representing. Okay, so there are input A, input B, and output Y. Three things are given. So from the waveforms, I can see that input is 0, 1, 0, 1, 0, 1. This is A. For B, I can say this is 0, 1, 1, 0, 0, 1. For Y, it is given 0, 1, 0, 0, 0, 1. Now, either you can write it in the truth table or you can directly see from there. So for the simplicity, I am writing it in the truth table. A is 0, 1, 0, 1, 0, 1. B is 0, 1, 1, 0, 0, 1. And Y is 0, 1, 0, 0, 0, 1. Now we need to identify the gate. One thing that you can see here, 0 and 0 is 0. Whenever 0 is any one input is 0, output is also 0. Any one input is 0, output is also 0. That means this represents AND gate. Only output is high or output will be high when both the inputs are high. So you can see that both high inputs and output is also high. Both the inputs are high, so output is also high. So you can clearly see that this is AND gate. This is AND gate. Now I think it's time is done. You can solve rest of the questions. If you have any doubt, you can ask. I'm ending the class here. Bye everyone.